So the first thing we'll do is review exam 1. And the first problem was the calculation of some limits. So we take the limit as x goes to infinity of 17x cubed minus 5x squared plus 10x plus 1 divided by 20x cubed plus 9x plus 21. And there are always more than one way to do a problem, but the simplest is to remember that when you have a rational function where the numerator and the denominator have the same degree, in this case, they're both cubics, they both have degree 3, the limit is just the ratio of the leading coefficients, 17 over 20. Okay. As I go through these, if there are any questions, please just interrupt and ask me to explain anything else that I need to explain. 1b is the limit as t goes to infinity of t minus 3 over t squared minus 9. This is the limit as t goes to infinity. Now you can't just, sorry, as t goes to 3. You can't just plug in t equal 3 because you would get 0 over 0. But you remember or you figure out that t squared minus 9 factors into t minus 3 over t minus 3 times t plus 3. Well, t squared minus 9 is t minus 3 times t plus 3. And these terms cancel. So this is the limit as t goes to 3 of 1 over t plus 3, which is 1 over 3 plus 3, or a sixth. And the limit as theta goes to 0 of sine of 8 theta over 7 theta. That's the limit as theta goes to 0. We could have it sine 8 theta over 8 theta, but then times 8 over 7, right? Because 8 over 7 times this 1 over 8 theta is 1 over 7 theta. This is 8/7. The limit as theta goes to 0 of sine 8 theta over 8 theta, and this limit is 1. So the answer is just 8 over 7. Okay. Any questions about that? All right. Problem number 2 is to compute some derivatives. If f of x is 17x cubed minus 5x squared plus 100x plus 1, when you differentiate, you get 17 times 3x cubed minus 5 times 2x plus 100 times 1. That's 51x cubed minus 10x plus 100. Okay. For b, we have the function h of x equals e to the x root x. By the product rule, h prime of x is the derivative of e to the x, which is e to the x, times the square root of x, plus e to the x times the derivative of the square root of x, that's x to the 1/2, and that's 1 over 2 times the square root of x. And there are other ways to write this. You can factor out e to the x, and you can put it over a common denominator, but that's fine the way it is. C is the quotient rule. R of x is a quotient of two functions, sine x over x. So R prime of x, you take the denominator and you square it. And on top, you have the derivative of the numerator, which is cosine x times the denominator. minus the numerator times the derivative of the denominator, which is just 1. So that's the answer. And part D, we use the chain rule, e to the x fourth. The derivative is e to the x fourth times the derivative of x to the fourth, which is 4x cubed. Okay. Any questions about this so far? Problem 3 is to compute the second derivative of the function f of x equals x log x. The first derivative by the product rule is the derivative of x, which is 1 times log x, plus x times the derivative of log x, which is 1 over x. So this is log x plus 1. And when you differentiate, log x plus 1. And when you differentiate log x plus 1, that's the second derivative. It's just 1 over x. The derivative of log x is 1 over x. The derivative of 1 is 0. So that's the second derivative. Right. Questions so far? All right. In problem 4, we have the curve 4x cubed minus 4x. And to make it easier to graph, I also factored this for you. This is 4x times x squared minus 1, or if you like, 4x times x minus 1 times x plus 1, but it's all the same function. What's the slope of the tangent line at x equal a half? Well, you take the derivative, dy dx. That's 12x squared minus 4. And if you evaluate that at x equal to a half, that's 12 times a half squared minus 4. A half squared is a fourth. So this is 3 minus 4, or minus 1. So the slope of the tangent line to the curve at x equal a half is minus 1. And at x equal 1, at x equal to a half, what is y? Y is 4 times a half cubed minus 4 times a half. This is 4/8, or a half minus 2 is minus 3/2. So the tangent line is y equals the slope minus 1 times x minus a half plus the value of the function at a half. Which is minus a third, minus 3/2. So this is minus x plus a half minus 3/2, or minus x minus 1. So the tangent line is the straight line y equals minus x minus 1. And we have to graph it by hand. But what does the graph look like? So we can tell that y is 0 at x equal 0 or plus or minus 1. At x equal to a half, the value of the function is minus 3/2. The tangent line is just the straight line through that point with slope minus 1. And we know that a cubic curve goes up, comes down, goes up again. So that's what the graph has to look like, roughly. Any questions about that? Problem 5 is to look at the function f of x equals x squared over x squared minus 1, which if you factor the denominator is x minus 1 times x plus 1. So this is continuous everywhere except where the denominator is 0, x equal 1 and x equal minus 1. Or another way to say this is it's continuous on the intervals from minus infinity to minus 1, minus 1 to plus 1, and 1 to infinity. And you have vertical asymptotes at x equal 1 and x equal minus 1. So this is minus 1 and this is 1. You have vertical asymptotes there. When x is between minus 1 and plus 1, this is negative. This function is 0 at 0, right? F of 0 equals 0. And it's negative between these vertical asymptotes. And so it looks like this. And if the absolute value of x is bigger than 1, then you could always write f of x is, so this is x squared over x squared minus 1. This is x squared minus 1 plus 1 over x squared minus 1. This is 1 plus 1 over x squared minus 1. So this is always 1 plus something positive if the absolute value of x is bigger than 1. So if this is the horizontal line, y equals 1, you have vertical asymptotes at plus and minus 1 looks like that, and that's the graph of the function. Okay. Problem number 6 on the exam is to use the definition of the derivative to compute the derivative of a certain function. So this is the definition of the derivative, and the function we're studying is f of x equals x squared minus x. So this is the limit as h goes to 0 of f of x plus h is x plus h squared minus x plus h minus x squared minus x over h. This is the limit as h goes to 0. When you expand this, you get x squared plus 2xh plus h squared minus x minus h minus x squared plus x. And we see there's some cancellation. X squared and minus x squared cancel. Minus x and plus x cancel. So what we're left with is this term, and this term. So this is the limit as h goes to 0 over h of 2xh plus h squared minus h. That's the limit as h goes to 0. If I factor an h out of that, I get 2x plus h minus 1. These cancel, and when h goes to 0, this is 2x minus 1. So everyone knows what the answer is. The idea is to prove the problem is to derive the correct derivative for this function from the definition. Any questions? Okay, and the last problem, you have the formula for the position of a particle that is free flowing only under the influence of gravity, minus 16t squared plus v naught t plus s naught. And we're told that where v naught is the initial velocity and s naught is the initial position. And we're told that the initial velocity is 0 and the initial position is 400 feet above the ground. So s of t is minus 16t squared plus 400. To find the average velocity, on the time interval from 1 to 2, that's the position at time t at time 2 minus the position at time 1 over 2 minus 1. This change in position over this change in time. What is s of 2? This is minus 16 times 4 plus 400 minus s of 1, which is minus 16 times 1 plus 400 over 1. The 400s cancel. This is minus 64 plus 16. This is minus 48 feet per second. So that's the average velocity over that time interval. The instantaneous velocity, v of t, this is s prime of t, is minus 32t. So the velocity at time 1 is minus 32 feet per second. The velocity at time 2 is minus 64 feet per second. Find the time required for the coin to hit the ground. Well, it hits the ground when the height is 0. So you want to find t when s of t, which is minus 16t squared plus 400, equals 0. So that means 16t squared equals 400. T squared is 400 over 16, which is 25. So it hits the ground 5 seconds after it's dropped. And what is the velocity of the coin at impact? The velocity at time 5 is minus 32 times 5 feet per second, which is minus 160 feet per second. Any questions about anything on the exam?
Do you know what was the average score?
No,
Okay.
but the scores on the whole were pretty good, but I don't know I don't calculate the average. All right. Okay, so much for the exam. lesson 14 has two parts. The first is implicit differentiation. So what does that mean? So this is in contrast to what we might call explicit differentiation. So this is versus, one versus the other. If you have a function like y equals 3x squared minus 5, you can just explicitly differentiate it. Dy dx is 3 times 2x or 6x. So that's no problem. Or if you have y equals 1 over x, dy dx is the derivative of x to the minus 1, which is minus x to the minus 2 or minus 1 over x squared. So this is explicit. Now, this equation could have been given to you in an equivalent form, namely x times y equals 1. Right? I mean, in both cases, the graph is just this rectangular hyperbola, y equals 1 over x, or xy equal 1. They're exactly the same. And you could look at this equation and say, okay, let me differentiate this with respect to x. So the derivative of xy with respect to x by the product rule is the derivative of x with respect to x times y plus x times dy dx. This is the product rule. On the other hand, xy is equal to 1. So this is the derivative with respect to x of the constant function 1, which is 0. And dx is 1. So we get y plus x dy dx equals 0. And now I can solve this equation for dy dx. X times dy dx is minus y, or dy dx is minus y over x. And you might say, well, wait a minute, something doesn't look right, because here, whether I write this in the form y equals 1 over x or xy equal 1, it's the same curve. And at any point xy on the curve, there's only one tangent line. The tangent line only has one slope, so there's only one derivative. But it looks like I got two different answers for the same problem. It looked like I got dy dx equals minus 1 over x squared. That came from just differentiating the function 1 over x. And here I got dy dx equals minus y over x. Of course, in fact, they are the same, because if xy equals 1, y does equal 1 over x. So this is minus 1 over x, or minus 1 over x squared. So they give exactly the same answer to any problem. But the difference is, here I had y explicitly as a function of x. Here I have y implicitly as a function of x. It's implicit because I don't have an expression that says y equals something. So the idea in implicit differentiation is you sometimes have some expression. So here's an example. You have a curve, y cubed plus y squared minus 5y minus x squared equals minus 4. Now in Maple, if you're in my class, I'll show this sometime later this week. There's a command called Implicit Plot, which draws the graph of this curve in the plane. All the points x, y that satisfy this equation. And at any point on this curve, there will be, almost every point certainly, a tangent line. So you have a point on this curve, and you want to find the slope of the tangent to the curve at a point on the curve. And I can't, it's too hard to solve this equation star for y explicitly. That is, this is a cubic equation. I just don't know how to solve it. I can't get y equals something. But I still want to find the slope of the tangent. So for this, we use what is called implicit differentiation. It simply is just differentiating with respect to x and using the chain rule. So for example, if y is some function of x, the derivative of y cubed with respect to x is the derivative of y cubed with respect to y times dy dx. This is the chain rule. And dy cubed dy is 3y squared dy dx. So I can express the derivative of y cubed with respect to x as something times dy dx. And I do that term by term for each of the terms in this equation. So let me write it as -4 equals y cubed plus y squared minus 5y minus x squared. So y is some function of x. We just don't know what it is. So everything on the right is a function of x. And that function of x is constant. So this is actually a constant function of x. For every value of x, whatever y is, this expression gives you a constant. And the derivative of a constant is 0. So if I differentiate -4, that constant function, I get 0. But that's the derivative of what's on the left that equals the derivative of what's on the right. And you can differentiate term by term. This is the derivative of y cubed with respect to x, plus the derivative of y squared with respect to x, minus 5 times dy dx, minus the derivative of x squared with respect to x. So 0 equals the derivative of y cubed with respect to x. We just saw what that is. That's 3y squared dy dx. The derivative of y squared with respect to x, differentiate with respect to y, you get 2y times dy dx. Minus 5 times dy dx, minus the derivative of x squared with respect to x, which is minus 2x. So let me just rearrange this equation. On the left, or on this side, if I factor out dy dx, I get 3y squared plus 2y minus 5 dy dx minus 2x equals 0. So if I bring this on the other side, equals 2x. So dy dx equals 2x divided by 3y squared plus 2y minus 5. So, for example, remember we have this curve, y cubed y plus y squared minus 5y minus x squared equals minus 4. The point 1, 1 lies on the curve. Because when I substitute x equals 1 and y equals 1, I get 1 cubed plus 1 squared minus 5 times 1 minus 1 squared. That's 1 plus 1 minus 6 minus 1. Is that right? Yeah, that's 2 minus 7. Oh, this is a 5. 2 minus 6 is minus 4. So this point lies on the curve. And the tangent also, the point 2, 0 lies on the curve. Because if I substitute x equals 0 and y equals 2, I get 2 cubed plus 2 squared minus 5 times 2 minus 0 squared is 8 plus 4 minus 10. Oops, sorry. 2, 0. X equals 2, y equals 0. So this is 0 cubed plus 0 squared minus 5 times 0 minus 2 squared is minus 4. So 2, 0 lies on the curve. What's the slope of the tangent line at the point 2, 0? Well, dy dx is 2x.
We can't see what you're doing.
Sorry, I'm just writing down the derivative. Dy dx is 2x over 3y squared plus 2y minus 5. When x is 2, this is 4. When y is 0, this is minus 5. So the tangent line at the point 2, 0 is minus 4/5. Okay, so let me just do some examples of how one carries out implicit differentiation. The point is you do it when you have an equation involving x and y, and you cannot or choose not to solve for y exactly. So suppose we look at the unit circle. X squared plus y squared equals 1. And for some point on the circle, we want to find the derivative, the slope of the tangent line. So we have x squared plus y squared equals 1. If we differentiate with respect x squared with respect to x squared plus y squared, that's the derivative of x squared with respect to x plus the derivative of y squared with respect to x, which is the derivative of x squared with respect to x plus the derivative of y squared with respect to y dy dx. The derivative of x squared with respect to x is 2x. The derivative of y squared with respect to y is 2y times dy dx. This is the unknown. That's what we want to find. On the other hand, x squared plus y squared is 1. So the derivative of x squared plus y squared is the derivative of the constant function 1, which is 0. So we get this is equal to 0. So 2y dy dx equals minus 2x. dy dx is minus 2x over 2y, or minus x over y. So that's the derivative. That tells us that at any point on this unit circle, the tangent line has slope minus x over y. So for example, if we take the point 1 over the square root of 2, 1 over the square root of 2, the tangent line has slope minus x over y. These are equal, so this is minus 1. Tangent line there, and slope minus 1. Suppose we have the ellipse. X squared plus 4y squared equals 4. If you want to put this in the more standard form with a 1 on the right, you have x squared over 4 plus y squared equals 1, or x over 2 squared plus y squared equals 1. When x is 0, y is plus or minus 1. When y is 0, x is plus or minus 2. So we have this ellipse. On this ellipse, there is the point square root of 2 minus 1 over square root of 2. Because this point satisfies this equation. If we take square root of 2 squared plus 4 times minus 1 over the square root of 2 squared, when you square the square root of 2, you get 2. When you square minus 1 over root 2, you get a half. So this is 2 plus 2, so this is 4. So right here, on this ellipse, is the point square root of 2 minus 1 over the square root of 2. And how do we find the slope of the tangent line at this point? So by implicit differentiation, 0, which is the derivative of a constant function 4, is the derivative with respect to x of x squared plus 4y squared. The derivative of x squared is 2x plus 4 times the derivative of y squared with respect to x, which is 2y dy dx. So that says 2x plus 8y dy dx equals 0. So dy dx is minus 2x over 8y is minus x over 4y. So at the point root 2 minus 1 over root 2, dy dx is minus x root 2 over 4 times minus 1 over root 2. So the minus signs cancel. 4 over root 2 is 2 root 2. And the root 2's cancel, and we get a half. So at this point on the ellipse, the tangent line has slope a half. Now, related to implicit differentiation is logarithmic differentiation, which is very convenient sometimes. So suppose you want to find the derivative of something given explicitly. For example, y equals x minus 2 squared over the square root of x plus 1. This is always positive. This is always positive except where x is equal to 2. And I'm only interested in where this function is positive. So this is positive for all x not equal to 2. And I can differentiate this because I know how to differentiate using the chain rule, the quotient rule, and so forth. But it's easier sometimes when you have an expression that involves a quotient of powers of simple things to take the logarithm. So the log of y, the log of this function, is the log of x minus 2 squared over the square root of x squared plus 1. And we use the various properties of the logarithm. The first is the log of a quotient is the difference of the logs. So that's the log of the numerator minus the log of the square root of x squared plus 1, which is x squared plus 1 raised to the power of half. And when you have log of something to a power, you can always pull the power out in front. This is 2 times the log of x minus 2 minus a half times the log of x squared plus 1. Now, if I differentiate with respect to x, the derivative with respect to x of log y, this is the derivative of log y with respect to y, dy dx. Derivative of log y with respect to y, this is 1 over y, dy dx. On the other hand, that's equal to the derivative of the right-hand side. So I have 1 over y dy dx equals the derivative of this. The derivative of the log of x minus 2 is 1 over x minus 2. So times 2 is 2 over x minus 2. Minus a half, the derivative of the log of x squared plus 1 is 1 over x squared plus 1 times the derivative of x squared plus 1, which is 2x. So I get 2 over x minus 2. These 2's cancel. Minus x over x squared plus 1. So dy dx, this is 1 over y dy dx. So dy dx is y times this expression. So that's x minus 2 squared over the square root of x squared plus 1 times 2 over x minus 2 minus x over x squared plus 1. If I expand that, one of these cancels one of these. So this is 2 times x minus 2 over the square root of x squared plus 1 minus this times this, x times x minus 2 squared over square root of x squared plus 1 times x squared plus 1, which is x squared plus 1 to the power of 3/2. And you can expand this and put it over a common denominator and so forth. Okay. So you'll have a number of homework problems using these, but we'll talk about that more on Wednesday. The second part of this lesson has to do with derivatives of inverse trig functions. So, for example, you have the function y equals the arc sine of x. That's the same as saying x. So what is the angle whose sine is y? X equals, so y is the angle whose sine is x. So x is the sine of y. And I can use this to calculate the derivative dy dx by implicit differentiation. So the derivative of x with respect to x is the derivative of sine y with respect to x, because x equals sine y. Of course, the derivative of x with respect to x is 1. This is the derivative of sine y with respect to y, dy dx. This is the cosine of y. So dy dx, where y is the arcsine function, is 1 over the cosine of y. Now, the trig identity you should never forget is sine squared theta plus cosine squared theta equals 1 for any angle theta. So cosine squared theta is 1 minus sine squared theta. So cosine theta is the square root of 1 minus sine squared theta. So let's use that here. 1 over the cosine of y is 1 over the square root of 1 minus sine squared theta. Sorry, sine squared y. And sine of y is equal to x. So we have this formula for the derivative of the arc sine of x is 1 over the square root of 1 minus x squared. Let me do one more of these. Suppose we have the function y equals the arctangent of x, and we want to find the derivative of the arctangent. So this is the same as saying x equals the tangent of y. And we remember the derivative of the tangent of theta for any theta is secant squared theta. And we also remember a relationship between the tangent and the secant. Remember from the identity, sine squared theta plus cosine squared theta equal 1. If we divide by cosine squared theta, we get sine squared theta over cosine squared theta plus 1 is 1 over cosine squared theta. But this is tangent squared theta, tangent sine over cosine. Tangent squared plus 1 is secant squared theta. So the derivative of the tangent of theta is secant squared theta, or 1 plus tangent squared. Now, if we differentiate x with respect to x, we get 1. That's the derivative of the tangent of y with respect to x. That's the derivative of the tangent of y with respect to y, dy dx. This is equal to secant squared y dy dx. That's equal to 1 plus tangent squared y dy dx. Tangent y is equal to x. That's 1 plus x squared dy dx. So the derivative with respect to x of y of the arctangent is 1 over 1 plus x squared. So these are two more trig functions whose derivatives you really need to know. The derivative with respect to x of arc sine x is 1 over the square root of 1 minus x squared. And the derivative of the arctangent of x is 1 over 1 plus x squared. Any questions about this? Okay. So that very quickly is the lesson for today. But I think I'm going to stop now. I actually just came from the dentist and some painkiller is wearing off and it's hard to speak. So I'm going to stop for right now. We'll review this on Wednesday and we'll also go over what is the lesson for Wednesday. Right? Are there any questions before we log off? All the exam grades were posted yesterday, so you know how you did. And I will have an office hour tomorrow at 3 o'clock in the afternoon. If at the same Zoom login, if there are any questions you want to ask about how you did on the exam. If not, then we will quit for the day. Everyone stay well. It's a beautiful day outside. Enjoy it. Now you have a free hour. Okay. Bye all.
Bye.